Hi everyone, in this video we are told for the angle theta is equal to 100 degrees, determine the reference angle. We want to find the x and y values of where the terminal arm intersects the unit circle to the nearest tenth, and we're also asked to determine the primary trigonometric ratios using the x and y values found in part B. So the first thing that we're going to do is we are going to draw an angle of 100 degrees on the unit circle. So we are first going to draw the initial arm, and if we draw the terminal arm, well, this would be 90 degrees here, and we need to go 10 degrees past that. So 10 degrees past that, let's estimate, and that's about right there. Good enough. Okay, so this is our x and our y value. Whoops. That's our x and our y value. And we're asked to figure out what the reference angle is. So the reference angle is going to be the angle drawn from the terminal arm down to the x-axis. So it's this angle. So this angle is going to be, let's call this angle phi. Phi is equal to, well, let's see, it's going to be 180 minus, oh yeah, I didn't draw the actual angle. This angle is theta, and it's 100 degrees. So 100 degrees plus phi is going to give me 180. So phi is equal to 180 degrees minus 100 degrees, which is equal to 80 degrees. So the reference angle is 80 degrees. In part B, so this angle here is 80 degrees. In part B, we are told the x and the y values of where the terminal arm intersects the unit circle to the nearest tenth. Now, the x value, remember that for the unit circle, we have, or let's think about how the primary trig ratios are defined. We know that the cosine of theta is going to be equal to the x value divided by the radius, but for the unit circle, since we've drawn this angle in the unit circle, the radius is just 1, so the cosine of theta is just going to be equivalent to the x value. If we want to figure out what the x value is, we can say that x is equal to cosine of theta, and that's from the symmetric property of equality. So x is equal to cosine of theta, and likewise the y value will be equal to the sine of theta. So the x value is going to be equal to the cosine of 100 degrees. And we can figure out what the cosine of 100 degrees is on our calculator. So cosine of 100, it rounds to negative 0.17. Let's say that we want to round this to the nearest, sorry, we should say the nearest hundredth. Let's round this to the nearest hundredth. So x is equal to negative 0.17. And our y value, which is equal to sine of theta, so we were going to say that y is equal to the sine of 100 degrees. And on our calculator, let's actually compute the sine of 100. And this is 0.98 when rounded. So it's approximately, x is approximately negative 0.17 and y is approximately 0.98. Now, let's think about why this makes sense. Well, the x value in the second quadrant is negative. The y value is positive in the second quadrant. So we should have that the cosine of 100 degrees should be negative. The sine of 100 degrees should be positive. Another thing to note is if you calculate the cosine of the reference angle, so let's say you calculate the cosine of 80 degrees, the cosine of 80 should be equal to positive 0.17. And if you try this out on your calculator, cosine of 80 degrees, you'll see that you do get the cosine of 80 rounds to 0.17. And same thing with the sine of 80. Sine of 80 degrees which is our reference angle, you should find that that's positive 0.98 when rounded. And it is when you compute this on your calculator. I recommend that you try this out because it leads to a better understanding of what we're actually doing here. So lastly, it says it wants us to figure out the primary trigonometric ratios using the x and the y values found in part B. So we're not going to get if we use the x and the y values of the that we found in part B, we're going to get an approximate value for the primary trig ratios, because we've rounded our x value and we've rounded our y value here. So we know that the sine of 100 degrees is approximately going to be 0.98, and because we have the sine of 100 is the y value divided by the radius, which is 0.98 over 1, because what I've drawn here is the unit circle, and I should scale my axes, which I forgot to do. It's always important to scale your axes. A lot of students forget that, but scaling is really, really important, and so is labeling the origin, actually, which I also didn't do. So let's just label that as 0, 0. Okay, so sine of 100 is approximately equal to 0.98, and cosine of 100 degrees is approximately equal to this x value that I've calculated, which is negative 0.17. And the tangent ratio, the tan of 100, is going to be approximately equal to, and again, this is because I've rounded to, the the y value divided by the x value. The y value is 0.98, and the x value is negative 0.17, and we can simplify this to being I'm not approximating this. We can simplify this to being equal to negative 98 over 17. So that is the tan of 100 is approximately equal to negative 98 over 17. You can try this on your calculator, see if it works, and calculate tan of 100. And then, so tan of 100 is negative 0.567, and negative 98 over 17 is the same value. So so these are the primary trigonometric ratios for 100 degrees. And again, the tangent ratio is negative because we're taking the positive y value, and since this angle is in the second quadrant, the x value is negative. So when you take the y value and divide it by the x value, you get a positive y value divided by a negative x value, and you get a negative tangent ratio.